You feel it before you see it. A sharp itch at the ankle, then another. You look down and catch something small, dark, and fast, moving across your skin and then gone before you can process what you just saw. That's a flea, and in the half-second it took you to blink, it may have already fed. Fleas are among the most physically remarkable insects on Earth, and almost none of what makes them remarkable is visible to the naked eye. They are flat, which allows them to move easily through fur and hair without being grabbed. They are armored with backward-pointing bristles that make them almost impossible to pull out once they've settled in. And they are fast, not in the way a fly is fast, but in the way that makes them nearly impossible to catch between two fingers. Fleas have been doing this for approximately 165 million years. Fossil evidence places flea-like insects in the Mesozoic era, feeding on the blood of dinosaurs and early mammals. Whatever they were doing then, it worked. They are still here. But the jump is what most people remember, if they see it at all. A flea can jump approximately 150 times its own body length. To put that in human terms, that would be equivalent to a person jumping nearly the length of 3 football fields from a standing start. But the jump itself isn't even the most impressive part. The speed of the takeoff is. Research published in the Journal of Experimental Biology by biologist Gregory Sutton and colleagues found that fleas generate forces up to 140 times the force of gravity during their jump, accelerating faster than the limit at which a muscle can contract. Which means fleas are not using muscle power to jump. They are using stored energy. Fleas compress a rubber-like protein called Resilin in a pad near their hind legs, loading it like a spring, then releasing it all at once in a fraction of a millisecond. The result is a launch that no muscle could produce directly, making the flea's jump one of the most energy-efficient mechanisms in the biological world. Engineers have studied this mechanism for applications in robotics. The flea solved it 165 million years ago. Now here's where the vampire comparison earns its name. A flea feeds on blood exclusively. Every stage of the flea's adult life depends on blood. Female fleas need blood to reproduce. Both male and female fleas feed multiple times a day, and unlike a mosquito which lands, feeds briefly, and leaves, a flea tends to stay close to its host, feeding repeatedly from the same animal or person until it's physically removed, killed, or forced off. A single flea can consume up to 15 times its own body weight in blood every day, per day. But the flea's real power isn't the bite, it's the life cycle, and it's the part of the flea's biology that makes infestations so brutally difficult to eliminate. Flea eggs are not laid on the host. The adult female lays eggs on the host, but the eggs are smooth and fall off almost immediately, landing in carpet fibers, bedding, floorboard cracks, and upholstery. There they develop through 3 larval stages before spinning a cocoon and entering the pupal stage. And the pupal stage is where the flea's survival strategy becomes almost unfair. Flea pupae are encased in a silk cocoon that is sticky enough to collect debris, providing excellent camouflage. They can remain in this stage for weeks, months, even up to a year, waiting for a trigger signal. That trigger is vibration, heat, and carbon dioxide, the same suite of signals that a warm-blooded host produces simply by walking into a room. This is why an empty house can appear flea-free for months and then produce a sudden explosion of adult fleas the moment someone walks through the door. The fleas were always there. They were waiting. And no standard cleaning routine kills pupae. Vacuuming, mopping, and standard surface sprays do not penetrate the cocoon. This is the primary reason why professional flea treatments require multiple applications spaced weeks apart, specifically timed to catch the newly hatched adults before they begin reproducing again. The flea's historical impact on human civilization deserves its own file because it is genuinely one of the most catastrophic in recorded history. The bubonic plague, which killed an estimated 30 to 60% of Europe's population during the 14th century, was spread primarily by the oriental rat flea, Xenocoela chaopes. The flea would feed on infected rats carrying Yersinia pestis bacteria, and when the rat population died off, the fleas moved to humans. The flea's feeding mechanism made transmission brutally efficient. When a flea feeds on an infected host, Yersinia pestis bacteria can multiply inside the flea's gut and block the proventriculus, a valve at the entrance to the stomach. A blocked flea becomes unable to actually digest blood. It feeds repeatedly, starving and frantic, and each time it attempts to feed on a new host, it regurgitates bacteria-laden blood back into the bite wound. The flea was not just a carrier, its physiology actively amplified transmission. Scholars who study demographic collapse estimate that the Black Death, driven largely by this mechanism, reduced the global human population by somewhere between 75 and 200 million people. A single species of flea, operating through a digestive blockage, helped reshape the course of human civilization. Modern fleas are smaller and less dramatic than their plague-era ancestors, but they carry their own concerns. Cat fleas, the most common flea species worldwide, can transmit murine typhus, cat scratch disease bacteria, and serve as intermediate hosts for tapeworms. Flea allergy dermatitis is one of the most common skin conditions in domestic dogs and cats, and resistance to common flea control chemicals has been documented in flea populations across multiple continents, meaning that the over-the-counter treatments many pet owners rely on are increasingly less effective against the populations they're most likely to encounter. Fleas survived the mass extinction that killed the dinosaurs. They survived the development of modern pesticides. They survived the introduction of every treatment cycle aimed at eliminating them. They are, in the most precise biological sense, one of the most successful parasites in the history of life on Earth. So the next time something moves at the edge of your vision at ankle height and vanishes before you can catch it, remember what you're dealing with. Not a minor nuisance, not a simple pest. Something that has been feeding on blood since before the first flowers bloomed, that stores elastic energy in a biological spring to launch itself faster than any muscle can fire, that leaves its eggs in your carpet and waits for you in a cocoon that soap and water cannot touch. Something that once helped kill a third of a continent, and something that, 165 million years on, is still very much at work,